Welcome! Up to 23% of Maths GCSE exam is comprised of geometry and measure. Angles and 2D shape is one of the most fundamental topics you must know if you want to be confident in answering that level 4 to 6 math exam questions. In this video, you will know all about the angles, angles on parallel lines, and angles on triangles, and we will use them to solve geometrical problems. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. In order to solve geometrical problems, we first need to understand the notion of angles and their properties. Angle is measure of rotation between two lines about the common point called the vertex. Angle is measured in degrees and we use the little circle to denote it. Angles measured in anti-clockwise directions are positive angles, and angles measured in clockwise directions are negative angles. Bear in mind that in these tutorials, angles are not drawn to scale, and we will also ignore the direction of the angle as it is not required at this level. Angles between 0 and 90 degrees are known as acute angles. When it is exactly 90 degrees, this is known as the right angle. Angles between 90 and 180 degrees are known as obtuse angle, and when the angle is exactly 180 degrees, it is known as the straight line angle. Angle between 180 degrees and 360 degrees are known as reflex angle. When the angle is exactly 360 degrees, we have a full rotation. Angles that add up to 90 degrees are known as complementary angles, and angles that add up to 180 degrees are known as supplementary angles. And the angles around the vertex always adds up to 360 degrees. When two straight lines meet at a vertex, two adjacent angles are created. If we let one of the angle be of size A, then the angle adjacent to this is going to be of size 180 minus A, as these two angles are on a straight line and they always add up to 180 degrees. Similarly, if we now extend this straight line a little further, we have two more new angles. Angles on this straight line also add up to 180 degrees. Hence, taking away 180 minus A from 180 gives us the angle A. This is equal to the angle number 1 and opposite to it. These two angles are known as vertically opposite angles and they are always equal. Angle number 3 and 4 also lie on a straight line and they also add up to 180 degrees. Hence the expression for fourth angle is going to be 180 minus A degrees. This is equal and opposite to the angle number 2. We can therefore conclude that any vertically opposite angles are always equal. Finally, all the angles around the vertex also add up to 360 degrees. Lines that never meet are parallel lines, and they are denoted by the arrowhead. A straight line which crosses the two parallel lines is known as transversal. There are three different types of parallel line angles that are created when the transversal crosses the parallel lines. First one is the alternate angle. Alternate angles are the two angles that are always on the opposite side of the transversal. These angles together make up the letter Z and they are always equal angles. And letter Z can occur in various different forms. So it can be like this or like that, and they are always equal angles. Second angle is the corresponding angles. These are always equal and they come in various forms of the letter F. And finally, the third parallel line angle is the allied angle. These angles are also sometimes known as co-interior or supplementary angles. These angles make up the various forms of the letter C and they add up to 180 degrees. And triangles are made up of three straight lines and all the angles on these triangles add up to 180 degrees. There are three different triangles based on the sides. Scalene triangles have none of the sides and angle equal. These small lines tells us that all the lengths of the triangle are of different length. Isosceles triangle have two sides equal and two base angles are equal that are located on the opposite side to the sides that are equal. We use the same two little dash line to denote the equal side. Equilateral triangle have all the sides equal and all angles equal. Since the total angle in triangles add up to 180 degrees, each angle is exactly 60 degrees. And three dash lines shows that all the sides are of the same length. Remember that the base angle of the isosceles triangles are located exactly opposite of the sides which are equal. When those two sides are equal, then the angles are located on the opposites to these sides. And if these lines are equal, then the base angles are going to change as well. Angles on any shape can be identified by using small letters or by using three capital letters. For example, in order to refer to the angle Y, we could write this as angle ABC or AB hat C, where the hat denotes that the angle is formed at B. Or simply, we can denote this as angle Y. In this example, we need to prove that triangle ABD is isosceles. Note that none of the angles and sides are drawn to scale, and we cannot assume that the angles are equal based on their size. In order to prove this, we must show that two angles of the triangles are equal, as all isosceles triangles have two equal angles. However, whenever we are proving this kind of geometrical problem, we must always back up our presented facts with the reason. From the diagram that we know that ABC is a straight line. Therefore, the angle ABD can be found by subtracting 124 from 180, as all angles on a straight line add up to 180 degrees. This gives us ABD as 56 degrees. We also know that the angles on a triangle add up to 180 degrees, so the angle BAD can be found by subtracting the given angle 68 and the angle ABD from 180 degrees to give us 56 degrees. As you can see, the two angles on a triangle is now equal to 56 degrees. This can only happen when the triangle is an isosceles triangle. Therefore, we have proven that triangle ABD is an isosceles triangle. In this example, we are given the angle 110 degrees and need to find the missing angle FGD. Notice that this shape has the parallel lines. We need to find a way to use our parallel line angles to relate the angles that we are given to the angles that we want to find. The angle FEG and 110 adds up to 180 degrees as they lie on a straight line. Therefore, the angle FEG is found by subtracting 110 degrees from 180. This gives us 70 degrees. The triangle EFG is an isosceles triangle, as the two dashed lines shows that the two sides are equal. Hence, the angle GEF and EFG must be equal angles because they are the base angle of the isosceles triangle. Angle FGD and EFG forms the alternate angles, so they are also equal. Hence, the angle FGD must be 70 degrees, and this answers our question. In this example, we have two parallel lines which are denoted by the arrow. This means we could use the parallel line angles and the given angles 32 degrees and 85 degrees to find the unknown angle FEG. Angle KIH and IGF forms the corresponding angles, so they must be equal. Angle FGE and IGF are on a straight line, so angle FGE is given by subtracting 85 from 180 degrees. This gives us 95 degrees. Angle EFG and HFB are vertically opposite, so they are also equal, as vertically opposite angles are always equal. Angles on a triangle EFG add up to 180 degrees. Therefore, angle FEG can be found by subtracting 95 and 32 from 180 degrees. This gives us 53 degrees. In this example, we are given three angles and a pair of parallel lines, and we need to find the angle X. Angle DEB and EBC are alternate angles. Therefore, EBG can be found by subtracting 35 from 110 degrees. This gives us 75 degrees. Angle BEF and EBC are supplementary angles and they add up to 180 degrees. Hence, the angle BEG is found by subtracting 25 from 70. This gives us 45 degrees. And finally, the angles on a triangle BEG add up to 180 degrees, as all angles in a triangle add up to 180 degrees. Therefore, the angle X is given by subtracting 45 and 75 from 180 degrees. This gives us 60 degrees. I hope you can now understand how to solve geometrical problems involving angles and parallel lines. Here is another question for you to try, and please post your answer in the comments below.